Hello everyone, welcome again to Hybrid Accounts, and today we're just going to take a look at growing annuity. You know, in the previous videos, we have taken a look at what an annuity is and perpetuity, but now we're just going to take a look at a growing annuity. You know, at first, when we spoke of the word annuity, we spoke of three major things. First, it was a fixed amount. Second, that fixed amount was being received in equal intervals. And third, we are speaking of the definite period of time. Definite period of time. This is what we did, right? Yeah, this is normal annuity. Now, when speaking of something called the growing annuity, we just go against one of these rules here. Which rule are we going to go against? Since we set the fixed amount, our amount now will not be fixed. So the amount would be variable. Variable usually at a constant rate. Variable at a constant rate. This is what we'll see. Now, let's just proceed and take a look so that we know what we have to do, right? All right, so we can just proceed here. So an annuity, as we spoke above, it might grow at a given constant rate. And what do we do in case it grows at a given constant rate? Now, I just simplified matters for you. Actually, I just refer to the normal formula for annuity, but you have to adjust it a bit. All right, so present value of a growing annuity is obtained in this way. You just take A, that is an annuity. That would have been amount that could have been received at the end of the period. But now you multiply it by 1 plus G. G, this means the growth rate, let's say 5%, 10%, etc. And you multiply by 1 minus 1 plus G or 1 plus R, all raised to the power of N over R minus G. Actually, this is a complicated formula. I could derive it, but actually it could be tiresome to a lot of people. So I've just decided to use it like this. All right, but what I really mean here, what do I really mean? I could just show it this way. What I really mean here is this one. Let's say that you expect that at the end of year one, you receive an amount of A. At the end of year two, an amount of A again. Here I just presume that the annuity is not growing. Year three, you have A again, and then you proceed all the way. Now what we do here, at the end of year one, since the annuity will be growing, you multiply by 1 plus G, that is a growth rate. And then at the end of year two, you already be having 1 plus G there. And so you multiply by 1 plus G again, which means that you would have to raise it to the power of 2, all right? Yes, so you could raise this to the power of 2. And when you go to year 3, you do the same. You multiply it by 1 plus G, but now you raise it to the power of 3, and then you proceed, all right? Now, by doing this, we really need to obtain the present value here. So if you need to obtain the present value, you would have to discount all these values. At the end of year one, you have A1 plus G. So you would have to discount it by 1 plus R. So I would say over 1 plus R. The same. For year two, I would have to discount it twice. So I would have to divide by 1 plus R, but again raised to the power of 2. As well as for year 3, I would have to do the same, 1 plus R raised to the power of 3. And then you have to add all these figures here for year 1, year 2, and year 3. If you add them together and make computations, you come to arrive at this figure here. And here, remember, you will have the geometric progression. Geometric progression. If you check this series, it would be the geometric series. And so you use the formula for geometric progression on sequence and series topic, and actually you derive at this formula. So this is what we do. So as I said, A1 plus G, what does this mean? Where A1 plus G represents cash flows at the end of year one, of course, because it would have grown, which is what will we will actually, which is what will be the first stream of cash flows. Actually, I've spoken of this issue here. You know, I'm just considering ordinary annuity. I'm not considering annuity due. If we had annuity due, that means we will add something. So this is for ordinary annuity. So in case you need the future value, you do not have to worry. You know, when you already have the present value, getting the future value is something very easy. Future value simply equals to present value times 1 plus r power n. We explained this very, very early. So you can just take this present value, the figure you have above here, and then you multiply it by 1 plus r to arrive at this figure. So this actually is not necessary. Not necessary to know this formula, just have to know the above one. So this is what we have to do, all right? And now we are ready to go to an example on growing annuity. Now let's just do this. Let's just do this example. I hope it's example number 8, yes. All right, let's take a look at this example. Take a look at example 8. It says that MMPLC has just entered into a contract that will provide it with 5 million at the end of each year for the next 5 years. You can just end up there first. You will have 5 million. That is an amount at the end of each year. At the end means ordinary. Each year means this is repetitive. It's either an annuity or a perpetuity, but we are told for the next 5 years. So it's a definite period of time, and so it is an annuity. So this is an annuity, right? So far it's an annuity. But additional information suggests that cash flows are expected to increase by 4% at the end of each year. So this is a growing rate. So the annuity isn't fixed. The annuity changes. It increases at a constant rate. That's why I call it growing annuity. And the discount rate of 11% is to be used. So you have everything at your disposal. All right? Now we are told, what would the worth of the receipts be now if 5 million is to be received? Actually, we presume that 5 million is to be received, but not indefinitely for 5 years. And then what would be the worth of the receipts now if 5 million is to be received indefinitely? Now, the word indefinitely reflects perpetuity. But for our case, we'll first deal with annuity alone. So I'll just deal with ordinary annuity, all right? So check here. Let's start with A, but A that we have started, and then we'll go back to the perpetuity, all right? Okay, so the data given, we have been given the annuity of 5 million, and then you have been given the period, that is 5 years, we are told. You have the R discount rate, that is 0.11, 11%, and we have the growth rate, 0.04. So to obtain the present value of ordinary annuity, you just go back to your formula. You have A times 1 plus G times 1 minus 1 plus G over 1 plus R, all raised to the power of N over R minus G, all right? You substitute. So you have A, that is 5 million. You multiply by 1 plus G. You have 1 plus G equals to 4%, that is 0.04, times 1 minus, the formula says 1 plus G, so 1 plus 0.04 over 1 plus R. So over here, 1 plus R, which is 0.1, all raised to the power of 5, divided by R minus G. R equals 0.1 and G equals to 0.04. You subtract those two and we'll have 21,194,703, just like this. So this would be your present value of your growing annuity, all right? And everything actually would be settled. And now let's just go to the concept here of perpetuity, right? So as for perpetuity, actually, I'll have nothing much to speak of. You could just come here, growing perpetuity. In case you have the growing perpetuity, what do you do now? Now we also presume this perpetuity to be ordinary, no? So a perpetuity might grow at a given constant rate. So you can just go to this formula here, and you know the perpetuity means n equals to infinity. So if you put n equals to infinite at the formula, you would find out that perpetuity, present value of growing perpetuity, equals to A times 1 plus G over R minus G. Simply speaking, Simply speaking, these figures here would cancel out, right? These figures here, this is the present value, 1 plus g of 1 plus r power n. Most of times G growth is less than R. So if growth is less than R, actually this figure here, as any increases, would be equal to nil. So 1 plus G of 1 plus R power n would be equal to 0. 1 minus 0 equals to 0. 1 times A plus 1, A times 1 plus G, you have A brackets 1 plus G over R minus G. So in case you have to deal with perpetuity, matters become much simpler. So the present value of growing perpetuity will be given as A brackets 1 plus G over R minus G, where this A1 plus G means first stream of cash flow. So in case you are provided with a question in an exam and you are told that the cash flows to be received at the end of year 1 or at the end of a certain year are this much amount, you would not need to plug 1 plus G here. You have to read the question and understand, right? It might arise in some question that this figure here is given all together. So let's just go and take a look at what we have to do. Let's go and take a look at our example 8 here. So you have to be very careful. I would just like to come back here. The question said that, and when PLC has just entered into a contract, it provided with 5 million at the end of each year for the next 5 years, but cash flows are expected to increase by 4 at the end of each year. The question could have said that it would receive 5 million. The question could have said that 5 million would be received at the end of year 1. If the question stated clearly that 5 million would be received at the end of year 1, that means that figure would already be 5 million, A times 1 plus G. So there would be no need to multiply by 1 plus 0.04. Right? So B says, what would be the worth of the receipts now if 5 million is to be received indefinitely? So if you are going to receive something indefinitely, this is what you have to do. The present value of ordinary perpetuity equals to cash flow 1 over R minus G. Cash flow 1 was not given directly, so you take 5 million times 1 plus 0.04 over R minus G, where R is 0.1 and G is 0.04. So you substitute and end up with 86,656 and 667, just like that, and all is done. Thank you very much. And if you haven't subscribed, subscribe for more updates. Thank you.